Okay, so the last section of this chapter is systems of inequalities in two variables. Now we did systems of linear equations with 2 variables, 3 variables, even more with matrices. We're going to do inequalities. We're not going to actually use matrices, but we're going to just graph and shade on all of these, okay? So let me just refresh your memory about inequalities, even though I 100% know y'all all did this in Algebra 2. So hopefully this is just a little review. But this is an inequality, so it's got a less than sign here, so that makes it an inequality. Anything that satisfies it makes it true. So, but the math word is kind of called satisfy. So for example, 2 comma 5, this would be my x, this would be my y. So if I plug these points in, that is 7. So is 5 less than 7? Yes, it is. So that satisfies the inequality. Okay, so let's do another one. So 2 comma 8. Okay, so if I do this, make sure you get the same number. This does not, this does not satisfy the inequality. Okay, so this one would not work. Nope, you're out. So if you're shading, this would not be one of the answers that you want to have shaded because it does not work. Okay, so let's get to the business here. I want to draw the graph of y is greater than or equal to 2x plus 3. So let me I'm going to do a very loose graph here. Not going to be that great, but you should make sure you get good points on your computer. All right, so I'm going to graph the line. I always make an equal sign, and then I'll always go back to the original. So if you rearrange this or anything, always go back to the original. So I'm going to graph this line right here. So plus 3, I'm going to rise 2, run 1, 2, run 1. Again, this is loosely sketched here. Okay, so here's my line. Goodness. Okay, it is going to be solid. It is a solid line. You do have to pay attention to this or you'll miss it on the computer. I often sit and grade all these tests when we do these, and you know, I kind of just take off a point here and there for a solid and a dashed line, but it's time to make sure you pick the right line. So this is a solid line because of the equal sign right there. Okay, that means this line is included in the answer. All right, it's going to make it all equal, but it is included in the answer. Okay, so now we have to decide where to shade. So I'm going to always go back to my original statement. I like to pick a point, and 0, 0 is my favorite because 0 math, if you're multiplying by 0 or adding 0, it's like the easiest thing ever, and I would like to make my math easy. So I'm going to pick 0, 0. If your line goes through 0, 0, do not pick it. Okay, if your line goes through 0, 0, pick a different one. 1, 1, 2, 2, 3, 3. Pick something that's not on the line. Okay, so I'm going to pick 0, 0. This is my x, this is my y. So 0 greater than or equal to 2 times 0 plus 3. So if I do the math, is 0 greater than or equal to 3. So here I'm going to say that again. Is 0 greater than or equal to 3? The answer to that is no, so that is false. So you have to think about it as a team. 0, 0 is over here, so everybody on his team is false. So you never want to shade false. You don't want to give trophies to the losers. You want to give it to the winners. So we're going to shade the true side, which is over here. Okay, so any point you pick over here, and including the line, should satisfy, and of course this goes on forever and ever and ever, my window is just small, should satisfy this inequality right here. And you could always pick a point and see. So like if I go drastic here, so like negative 10 comma 10, it should satisfy because it's in that area. So I've got 10 is greater than to 2 times negative 10 plus 3. So is 10 greater than or equal to negative 17? The answer is yes, because it's over here somewhere, and it should satisfy that inequality. All right, and the boundary, they ask you about state the boundary of the region. Well, the boundary is this line, so all the answers fall on or above this line. So I'm going to say that again. They fall on or above the line of y equals 2x plus 3. So the boundary is that graph right there. Okay? All right, let's do another one. The only thing you might not have done in Algebra 2, some of you may have, is quadratic. Okay, so here's a quadratic. I'm going to graph it just like I would if there was an equal sign. Again, I'm going to do this loosely because you'll all have calculators that you can graph these in and get exact points. So my U shape, look, oh, that's not good. I start off like this. The -3 means I go down 3. So I'm going to then make let's see if I can do a good job here. I'm going to make my graph look something, I don't know, like that, okay? So I went down 3. So again, I don't go through 0, 0, which is good. If I went through 0, 0, I'd want to pick a different spot. So I'm going to use 0, 0, and I'm going to plug it in to see what happens. So is 0 greater than -3? That is true. So everything, oh, you know what I didn't do? I told you to pay attention, is that it needs to be dashed. So I'm going to go back and I should have, let's see if I can do this. Let's do partial. I'm going to dash it. Again, you can do, like I think on your computer, you can, it's just like touching the button of a line. So before you click anything, just like I did when you double check, before you click submit, make sure you have a solid line or a dashed line. This is a dashed line because of the greater than. I just drew my line without thinking about it, but always go back and check. Okay, so this is true. So this is going to be in here. Okay, again, we want to, make sure before you click that submit button, did I shade the right side? And if you want to pick a point, you can to make sure. You can do a check. Anything in here should satisfy that inequality, and make sure you either had a solid or a dash, and you know which one you do. In this case, we needed a dash line before you hit submit. Again, I think this is pretty, just kind of a review for you guys as we did this in Algebra 2. Okay, so the boundary here is going to be above this line. It doesn't include this line because remember we made it dash. So it is everything above this quadratic right here. Okay, the other one was on and above, but this one's just above the parabola. All right. All right, so the other thing we do is what we really wanted to get into in this section, they just did those for reviews, is solving a system of inequalities. That means more than one. So here I have 2. I think on your homework you might have a couple that have 4 lines, and you just graph the lines and you shade kind of where they tell you to shade. Okay, so let me get the graph going. Okay, and I'm going to make note right now, these are both dash lines, so I'm going to write that down so I don't forget. Now this one I need to put into y equals mx plus b form, so I'm going to kind of write it over here, and I'm just going to ignore the inequality for right now because I don't care about it. I just need the line. I need the boundary. So I'm going to do like that, okay? And I'm going to graph this first. So 4 over 3 is 1 1/3. You know what? I'm going to make my tick marks first. Okay, so 1 1/3. So, about yay. And then I'm going to go down 2 over 3. So down 2, 1, 2, 1, 2, 3. Again, this is loosely graphed because my graph is not that great. All right, so I'm going to make a dashed line. 1, 2, 3. I'm going to make a dashed line through these points right here. Ugh. Again, my human tick marks is not making this the most accurate, but there we go. Okay, so there's that line right there. So that is that line right there. Okay, now I'm going to come back and I'm going to do this as just a quadratic, and it's just like a quadratic looks like. There is no moving it left or right or anything like that. So I'm going to make it look like it's so hard to draw. Freehand. That's terrible. Let me try that again. Okay. There we go. That's a little bit better. Now, I do have to make it dashed. I couldn't really do that freehand, so I'm going to come back and kind of erase a little bit because I needed to make it dashed. I knew that I did, but I couldn't draw that dash very well freehand. Okay? All right, so they're both dashed. Now I have to figure out where to shade. So I'm always going to go back to my original. What I mean is these two right here. Okay, so I'm going to start with this one right here. It does not go through 0, 0, so I'm going to plug in 0, 0. So 2 times 0 plus 3 times 0 less than 4. So this gives me zeros less than 4. So is that true? That is true. So on this case, I would be shading. I'm going to do this. I'm going to show you, and then I'm going to kind of do it a little bit less than. So it would be all down here. Does everybody understand? So what we're going to do though, and since I can easily erase this right now, we're going to see where they overlap. So we're going to kind of just have a visual right now of where we were shading that, because this is going to get messy if I don't erase that right now. So I'm going to do some arrows that just kind of point in this direction so we can kind of remember that that one was going that way. All right, so now let's do this first one right here. Y is greater than x squared. Now here's our problem. It goes through 0, 0. We cannot pick 0, 0. So we need to pick something else. I'm going to pick something kind of drastic out there. Okay, so it's either going to be, think about a quadratic, it's either going to be on the outside of the quadratic and outside of the U or the inside of the U. Okay, so I'm going to pick something like, I'm going to show you, look right here. I'm going to pick something right here and see if it's on the inside of the U. So let's say that's 0, 10. You know, I'm just going to do something, like I said, very drastic, very easy math. Okay, so I'm going to do it right here. So 0, 10. That's what I'm picking. This is my x, this is my y. So y is 10, and then 0 squared. So is 10 greater than 0? The answer is true, so it is. So it's going to be shaded. I'm going to do this really quick, and then I'm going to give you a visual. It's going to be shaded inside this U. So can everybody kind of see where it would overlap? See, this is going this way. So do you see where the area it would be where it overlap? If you don't, I'm about to show you. So let me erase this shading here. I'm also going to erase this big blob I made so you don't get confused. Okay, so erase these lines too. All right, so here's my graph. It's a very clean kind of graph, and I'm going to show you where they overlap. They overlapped right in this area right here. Okay, because remember, this went down this way, and this was in this area right here. So that is the answer. That's the only area right here that solves both of these equations. You have to satisfy both of the equations. Okay? So hopefully you remember that from Algebra 2. A lot of times in my classes, I let you use different colored pencils so you could see where you overlap. In this case, in the computer, you only need the area where they overlap. You can't put in both and assume they know. It's only the area where they overlap and where it would satisfy both of the inequalities. So let me know if you have trouble with that. So we would shade, so the boundary here would be below this line and above our quadratic. So it's below below this line above our quadratic. Okay? So it's, I say where it overlaps, the intersection is the better word to that. So it's the intersection of these two graphs. Okay? So it does not include these lines because there are dashed. I want to make that clear. I think there is a couple of questions that ask you if it includes or excludes the line. These lines are not included in the answer because they're dashed. So that is not the case. Okay, I think you should be able to do all of the problems. I don't remember. I don't think there's that many actually on this. Pay attention to the graphs. Let me know. Make sure your lines are solid or dashed when you enter them. And you get 3 tries, so please make sure you're paying attention every time you hit submit. All right, love you guys. Let me know if you need any help. We will touch base on our Zoom calls about our test on Thursday. It will be the same time, 1 to 5. If you have an issue with the time, let me know before the test, not after the test. That's too late. All right, thank you.